Okay, we're going to take a look at the inverse trigonometric functions. See what kind of applications we can get going with these. Of course, the three major ones are sine, cosine, tangent. So arcsine is the inverse function of sine. We'll take a look at the domain and range here in just a little bit later with the unit circle. Of course, with the unit circle, you can never get greater than 1, never get less than -1. This also makes sense if you just think about the trig ratios. Since sine is opposite over hypotenuse, hypotenuse must be the largest side. You're obviously never going to get a value greater than 1. Of course, arc cosine is the inverse function of cosine. And again, you know that when we're looking at cosine or sine, we're trapped between +1 and -1. Talk about the range again in a minute when you see the unit circle. Tangent, of course, is a little bit trickier. Tangent, of course, can vary between -infinity and +infinity because it's a ratio of sine divided by cosine. And as cosine approaches 0, x approaches either +infinity or -infinity. Now, on the calculator, we've got some abbreviations for space. Normally they put sine to the -1 power instead of arc sine, cosine to the -1 instead of arc cosine, etc. Got to remember when we're doing functions that exponent of -1 means inverse function. It is not a traditional exponent. So I have the inverse sine button. That's what they use for arc sine. If instead I want the fraction 1 divided by sine, I'd have to use cosecant, which you'll notice is not a button on the calculator. Okay, back to the unit circle. Why on earth was the range what it was? Well, if we take a look at cosine, when we go between 0 and pi radians, we get this full spectrum of possibilities from +1 to -1. However, that is not true for sine. In quadrants 1 and 2, cosine varies between positive and negative, but sine is always positive. So for sine, I've got to look at quadrants 1 and 4. Now this is a little bit sneaky, because if I look at perhaps say 11 pi over 6, that's not in the range between -pi over 2 and pi over 2. So if I want to grab an answer off of say 11 pi over 6, instead I have to respond with -pi over 6, right? A coterminal angle that's negative. Of course, whenever possible, we want the exact value. So for sine, I'm limited to quadrants 1 and 4. I need a value of -1/2. So I find a location where sine is -1/2. But again, instead of saying 11 pi over 6, I'm going to say -pi over 6. Right? Because from our starting point of 1, 0, that's how far I travel, -pi over 6. Okay, got to figure out where sine has a value of positive √3/2. Again, in quadrants 1 or 4 only. Quadrant number 1, that happens at pi over 3. Inverse sine of 2. Yeah, right. Like sine is ever going to be as large as 2, right? It can't go higher than 1, can't go lower than -1. We'd never get a value of 2. So inverse function of sine for 2, undefined, no solution. Better do at least one cosine, at least one tangent. So when I'm looking for arc cosine of -√2/2, like I remember I'm looking for quadrants 1 and 2. Sure enough, in quadrant number 2, I find cosine can be -√2/2. So the angle is 3 pi over 4. Arctangent of root 3 over 3. A little trickier to recognize. The answer is pi over 6 if you want to know why. Remember, tangent of theta is sine of theta divided by cosine theta. So if I take a look at the quadrants that correspond to that point and manipulate them, sure enough, it's root 3 over 3. Tangents are also tricky ones to try to figure out. Sine and cosine are pretty straightforward. Okay, here's an actual screenshot from IXL. And of course, sine of theta equals negative 0.9. Sorry, but that's not off of one of our special right triangles. It's not going to be on our unit circle. Now, I've got to be careful. If they ask for radians, make sure your calculator is in radians. If they ask for degrees, make sure your calculator is in degrees. Oh, my calculator's set for radians right now. If I try to do inverse sine when I'm in radians, I'll get an answer of negative 1.11977. That's in radians. I don't want radians. Change it to degrees. Okay, so I've switched my calculator to degrees. Now notice I can do the same entry, inverse sine of negative 0.9, but now I've got a correct answer in degrees, about negative 64 degrees. Directions asked for the nearest hundredth, so I'll get around the 2 decimal places. Uh-oh, I don't have an arc secant button on my calculator, neither do I have a secant button on my calculator. Well, of course, secant is the reciprocal of cosine. So I'm really just trying to solve cosine of theta equals 1 over 1.6. So of course I can do the arc cosine to figure out the angle, about 51 degrees. The directions asked for the nearest hundredth, 51.32 degrees. So the assignment today from IXL, M8, you're going to be exploring inverses of trigonometric functions.